One important alignment to check for on your bandsaw is to make sure that the two wheels, the top and the bottom, are coplanar to each other. In other words, you want to make sure that the faces of both of the wheels are perfectly in alignment with each other. To kind of show that, if this is the two sides of the top wheel and the bottom wheel, they need to be perfectly in alignment with each other. To do that, you can go ahead and put a straight edge and put it up against the top and bottom wheel and see if it's flat against the two. But sometimes that's not easy to do, especially in an example like mine, where I can't get around the top and also the fence. I need to kind of work around all of this. So to go ahead and check and see if they're in alignment, since the straight edge won't be able to go flush up against it, I put extensions on the straight edge. In this case, I went ahead and on a straight edge, I clamped on a board on the top and on the bottom. And I put little notches in there, and these notches will fit around the hubs that are in the center of the wheel. Now, all I need to do is place this up against the two wheels, and I'll be able to see when I'm against the bottom wheel is if the top wheel is perfectly in alignment with the bottom. I'll go ahead and move the camera to get a closer look. Since the bottom wheel is stationary and doesn't tend to have much in the way of adjustments on it on most bandsaws, I'll go ahead and line up this board on the top and bottom first, making sure that it's flush against the wheel. Once I do that, I'll go take a look at the top wheel. So while holding the board against the bottom wheel, I go ahead and take a look and see if the board is lined up on the top as well. And I notice that on the lower edge it's touching, but on the top edge it isn't. That's not necessarily a problem because most bandsaws you can tip the top wheel for blade adjustment. I'm going to go ahead and rotate that tilt right now until I see that both the upper and lower edges of the upper wheel are touching the board. Next, I'll take a look down at the bottom wheel, and if the edges are touching on both of that as well, then I know that the two wheels are perfectly in alignment with each other. If it turns out that your upper wheel is not completely in line with the lower wheel, it might be necessary to adjust the upper wheel. Most bandsaws have that adjustment built into them. Just check your manual. If that adjustment is not available, you may have to take the wheel off and add a shim to the upper wheel shaft if that's where the problem is, or push the lower one out by making adjustments there. Either way, if they're out of alignment, it can cause you to have a bit of a twist and rack to your blade, so you definitely want to do something to get them back in line. One way that vibration can end up getting introduced into your bandsaw is by a buildup of dust, especially on the lower wheel. As the blade turns, as it brings sawdust down, it can get trapped between the blade and the wheel and cake in place, especially if you're using softwoods like pine. My particular saw has a bristle brush on it that rubs against the blade. You want to make sure that if one is already attached, that it's on there nice and tight and pressing pretty hard against your wheel. If you don't have one, you can actually go ahead and get a wire bristle brush and find a way to clamp it in place, and that helps quite a bit. The other thing that you need to do occasionally is check and see whether there's a buildup or not, and if so, you can actually sand it off with some coarse grit sandpaper, rubbing it in place. It also ends up kind of cleaning up the tire a little bit and giving you a nice smooth surface. If you're able to run your bandsaw with the door open, go ahead and remove the blade, and you can go ahead and run the lower, turn it on without a blade in place, and it's really easy to go ahead and sand that smooth. If there's a safety attachment on your bandsaw, like I have on mine, I just go ahead and I rotate the blade by hand as I'm continuing to sand and clean it up. Same thing is done with the upper blade as well to make sure it stays clean also. Never, ever try to do this with the blade in place and turning the power on. It's extremely dangerous, and you want to make sure that you keep all of your fingers. Vibration can also be caused by your wheels being out of balance. In order to check for that, it's pretty simple. For the top wheel, just go ahead and remove the blade, give it a small spin, And when it stops, you'll go ahead and mark the bottom of the wheel. When you do that, you'll know pretty much what seemed to be the heaviest part of the wheel, and then you'll spin it again. Do it 3-4 times and see whether you're consistently marking the same spot of the wheel or not. If you are, that means that that's the heavy part of the wheel, and you'll want to go ahead and add some sort of weight to the opposite side. So after giving this one a few spins, I've noticed that it's pretty well imbalanced already. The marks have not all been in the same spot. The manufacturer actually balanced this wheel in advance. You can see that right here where they have a couple of marks on there. Balancing the bottom wheel is basically the same thing, but you actually need to remove the belt from the motor. If it's a direct drive, that's kind of tricky to do. You actually have to take the wheel off and spin it on a dowel or something. If it's run with the belt, just take off the belt, give it a spin, and make the same marks. I indicated before that you can add weight to the opposite side of a heavy side. Optionally, you can just start drilling a few small holes on the side that's the heaviest and seeing whether that takes the weight off. Also critical to reduce vibration is to ensure that your guide blocks are placed very close to the blade. You want them close enough so that way they don't vibrate or move back and forth, but you can still move smoothly through them. Depending on the kind of system you have, if you have ball bearings, you can put them up tight. Cool blocks you press in tight. I've got ceramic blocks, so I just leave a hair's width of space between the guide and the blade. Whatever it is, just make sure you don't have large gaps between your blocks and your blade. Vibration on smooth cuts can also be caused if there's a kink or a bend or twist in your blade. In order to see if you have one, you can use a dial indicator, as I've shown up here. And what you do is you set the indicator so it's touching the back side of the blade away from the teeth. When you slowly rotate the blade, you'll notice the indicator barely moves at all. However, there may be spots where you'll notice a jump or twist of some sort, like right there. If it's significant, you can find that spot and see if it's possible to go ahead and give a little bit of a bend or twist to the blade in order to remove it. For the most part, very small movements don't cause much of a problem, but jumps like you just saw there can be a big issue. For example, where the weld joint is, you'll often see something. You might discover that you'd have to lightly file down where the weld joint is. Either way, identifying whether you have a problem with your blade is another way to check and make sure you don't have vibration issues. If for some reason you don't have a dial indicator, or most people I know don't, the other thing you can do is just take something that's more solid. You can use a piece of wood, a metal bar or something, and just hold it against the blade as you rotate it. You tend to be able to feel vibrations, and if there's a particular spot where it feels like there's a high or low spot, you can tend to feel your hand move back and forth and identify it that way. Of course, you also want to make sure that your table is 90 degrees to the blade. Once you've got your blade adjusted and tightened up, you want to go ahead and get yourself a good square. Hold it flat on the table, line it up to the blade, avoiding the teeth, and take a look and see if you see any light shining through between the top and the bottom. If it's nice and flat against your blade, you know that your table's set to 90. Alternatively, if you've got yourself a good digital meter as well, you can zero it on the table and then go ahead, put it on the flat side of your blade and checking to see if that says 90 as well. When placing a new blade onto your bandsaw, you need to tension it first before you set the tilt of your top wheel. The top wheel tilt allows you to position this blade either toward the front, back, or middle of the tire. It's wrapped around it. You tension the blade, spin the wheel by hand a few times, and see where it ends up sitting. There are people who claim that you should always have the blade towards the front with the teeth hanging off the tire. I personally don't agree with that. The tires are designed to be able to handle the cushion of the blade running over the top. As long as the blade is tensioned, it won't cut into the tire. Here's the reason why I don't always agree with placing the teeth toward the front. The top of the tire tends to have an arch, which I'm over-exaggerating here. If you place a straight blade over it and you move it toward the front, the blade will tend to have a bend to it. Whereas, if you place the blade toward the center, that little bit of a bend will end up causing the blade to ride much smoother, and you don't end up with a twist in the blade that you would get in this first example. If I have a very, very wide blade, like an inch or inch and a quarter, I'll go ahead and tend to move it so that way the teeth are more toward the front. But on a small blade like you see here, it's toward the back. What I like to do is have the blade pretty much centered on the wheel with the teeth a little bit forward. If you're getting good, clean, smooth cuts, placing it elsewhere on your bandsaw, that's fine. There's no reason to make any changes. But for me, this has worked rather well, and I find that I end up with good smooth cuts this way. All blades on a bandsaw have something what's known as drift. The blades tend to cut a little bit more to the left or the right. Extremely good sharp blades may not show any drift at all. Other ones may have severe drift. In other words, when you push a piece of wood through the blade, it may try to push the wood a little bit to the left or a little bit to the right. When you're cutting freehand, that's not really an issue. However, when you're using a fence, it can be a big problem because as you're pushing through, because the blade's trying to push one way or the other, it may try pushing a little bit more into the fence or away, and you end up having unsmooth cuts and putting added stress on your blade itself. In order to resolve that, you can take the fence and adjust it a little bit in or out, depending on whether the drift is leaning a little bit to the left or to the right. In other words, you want to see if the blade is trying to push to one side or the other. If you were to be cutting into a piece, you would end up with a kerf like that being cut into a piece of wood. If the blade is pushing one way or the other, you'll notice that the blade might be sitting more to one side of the cut or the other, and if so, you know to go ahead and tilt your fence to the left or the right accordingly. Let me go ahead and show you what I'm talking about. Using a piece of plywood, I'm going to go ahead and cut just part way into the board. I use plywood because there's no internal stresses in plywood, like there may be in other wood, which would cause the gap to change because of the movement of the wood. Plywood doesn't do that. What I'll do is lock my fence in place and then just make a cut part way in, and we'll see what it looks like. When the blade stops, I'm going to go take a look and see where it is with relationship to the kerf I just cut. All right, I went ahead and marked the scratch piece, and you'll notice that on the right side, there's a bit of a gap between the kerf and the blade. But when I look to the left, the blade is actually touching the left side of the kerf. That means that the blade is drifting off to the left, which means that I need to take the fence and move it so that way it's tipped a little bit more to the left, and that'll compensate for this. I'm going to go ahead and do that now, and we'll make another cut. The way I do it will be different than the way it'll be for every particular brand of bandsaw out there. Take a look at your instructions that came with it and see how you go ahead and adjust your fence accordingly. They all have a way of doing it in order to account for this drift. All right, I've gone ahead and taken the fence and twisted it a little bit over to the left. I've slid it over so that way I'm ready to make a new cut. Let's see how this one looks. All right. I can take a look now and I see that there's the same amount of space on the left and right side of the blade inside the kerf. Your blade will definitely lose performance if you end up having pitch buildup. On both bandsaws and table saws, it's critically important to remove any pitch that builds up on the blades. You'll notice that there's a little bit of pitch that's starting to build up on the blade now. It's best to get rid of it now before it builds up anymore. You end up with a cascading effect of the more the pitch that builds up, the more it'll end up cutting hotter, burning the wood, drawing more pitch out, causing more to stick, and you have a really bad effect, which will end up dulling your blade permanently if you're not careful. You'd be surprised at how much better your blade cuts once you remove the pitch. I like to go ahead and get a good pitch remover designed for that. This particular one is made by CMT. I'll go ahead and give it a spray, let it soak just for a little bit, and then get a brass bristled brush, do not use steel, which can dull the blade, and give it a good scrub on both sides. It's a lot easier to do that with bandsaw blades when they're coiled up like this, because basically you can do it 3 times faster. Once it's done, rinse it off. I'm here at my shop sink. Dry it and make sure it's completely dry before it goes back on your saw. Well, I don't know if you noticed how dirty this blade was before I started. It didn't really seem that bad, but a lot came off of it. And now that it's done, it actually looks like a totally different, brand new blade ready to go. And it even feels sharper to my fingers.